Alright, our second problem is the limit as x approaches 0 of the tangent of 5x over the sine of 2x. You might look at this and be a bit bewildered, but let's take this one step at a time. First of all, we can simplify this part. We can make this the limit as x approaches 0 of 1 over the sine of 2x times tangent of 5x over 1. If you think about it, tangent of 5x is the same thing as saying sine of 5x over 1 times 1 over cosine of 5x. Now that we've done that part, we need to make sure that we can use the theorem that we just learned about. I'm going to change colors and show you in red what you need to multiply each term by. You need to multiply the first term by 2x, and then 2 on the bottom also. The second term you need to multiply by 5 on top and 5x on bottom. The third term you can leave alone. The reason why you can do this is because here the 2's cancel out, the 5's cancel out here, and the x's from here and here will cancel each other out. So, moving on. I can rewrite this again as the limit as x approaches 0 of 2x over the sine of 2x. And now I'm going to move this 2 over here, so it'll be 1/2. And I'm also going to move this 5 out in front, so it'll be times 5 over 1. And then I'm going to simplify this term to the sine of 5x over 5x times 1 over the cosine of 5x. This becomes 5/2. And now we're going to evaluate each term. This one you might be a little bit confused on because up here we see that sine of x has to be on top. However, if you think about it, if we reverse this so that it's the limit as x approaches 0 of x over sine of x, in the original equation this was 1 over 1, so even if we took the inverse of this, it would still be 1 over 1. Therefore, this part is still 1, so we're going to do 5/2 times 1. The second part is 1, and the third part, if you plug in 0 for x, becomes 1 over, this becomes 1 over cosine of 0, which is 1. So 5/2 times 1 times 1 times 1 is 5/2. Alright, our next problem is a little tricky. You look at this and you wonder, what should I do? I'm telling you, C is a magic letter. Let's think conjugate. What we're going to do is we're going to multiply the top and the bottom by 1 plus cosine of theta. This becomes the limit as theta approaches 0 of theta squared times 1 plus cosine of theta all over. If you distribute and FOIL all of this, it becomes 1 minus cosine squared of theta. Ding, 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 ding. Okay, this is gold. Folks, I'm telling you, if you remember all the way back to trig, then you will remember that sine squared theta plus cosine squared theta equals 1. Therefore, 1 minus cosine squared theta is equal to sine squared theta. Therefore, we can make that substitution and say the limit as theta approaches 0 of theta squared times 1 plus cosine of theta over sine squared theta. You might be looking at this and you're wondering, well, what do I do now? Well, now you're going to split up the fraction. This is going to become the limit as theta approaches 0 of, remember theta squared is really the same thing as theta times theta. So this will become theta over sine of theta times theta over sine of theta times 1 plus cosine of theta over 1. When you evaluate all of this, theta over sine of theta is 1. As we established in the previous problem, you can still take the inverse of this function and have it equal 1. So you have 1 times 1 times 1 plus the cosine of theta over 1. If you evaluate this, this is 1 plus the cosine of 0. The cosine of 0 is 1, so 1 plus 1 is 2 over 1 is still 2. So you're taking 1 times 1 times 2, which gives you a final answer of 2. Alright, the first thing that I notice about this problem is that right away you can simplify this top part. Remember again, sine squared theta plus cosine squared theta is equal to 1. 1 minus cosine squared theta is equal to sine squared of theta. Therefore, we can rewrite this problem as the limit as theta approaches 0 of sine squared theta over theta. We can break this up even more and say the limit as theta approaches 0 of sine of theta over theta times sine of theta. This first part becomes 1 because of the theorem up here. The second part, the sine of theta, this, when we plug in theta is 0, the sine of 0 is 0, so 1 times 0 is equal to 0.